We have two closed containers, a smaller one as shown here with a volume V, the bigger one has a volume, let's say 4 times V. And they are separated by a yellow barricade or a separation layer. And the volume, the smaller chamber is different from the bigger chamber, or the smaller container, whatever it contains is not allowed to get into the bigger container. They are separate containers. Now, the temperature of the gas, there is an ideal gas that's filled in the smaller container and also in the bigger container. Now, the temperature of the gas in the smaller container is T and the pressure is P. Same is the case for the bigger container also. The temperature is T and the pressure is P. Now, the question is to find out if we separate or remove this barrier out and the layer out, and we allow the two chambers to become one, what would be the pressure? What would be the pressure in the newly formed bigger container? Let's call that pressure P new or Pn. What is Pn is the question now. Now what we need to do is see what is not going to change from the initial scenario to the second scenario. Initially, the number of moles in the small chamber, let's call it Ns, and the number of moles of the ideal gas in the bigger chamber, let's call it Nb. Even after they become one container, both of them, Ns plus Nb is not going to change. This total of Ns plus Nb is going to be the same number of moles. We also know from the equation of state for an ideal gas that PV equals nRT, where P is pressure, V is volume, N is the number of moles, R is the gas constant, and T is the temperature. From this, we can find out that N is going to be PV by RT. So, Ns, the smaller chamber, is going to be PV by RT. It's going to be PV by RT. And Nb in the bigger chamber, the number of moles is going to be P is pressure is P, but volume is 4V. So let's call it 4V by R, and the temperature is the same, which is going to be T. Now this is the initial scenario. Now after the chambers are combined, the containers are combined, it's going to be the same. Ns plus Nb is going to give us, if we add both, let's add both PV by RT plus 4 PV by RT is going to be the new chamber, the number of Ns plus Nb, the number of moles is going to be same as this total, and that is given again by PV by RT, where P is the new pressure. That's where we are trying to find out what is going to be the new pressure. Volume is 5V, 4V plus V, which is 5V, by R and T are not going to change. T is the same and R is a constant. Now if we combine the left hand side, we get 5 PV by RT. This is going to be equal to 5 PNV by RT. So we can clearly see from this that RT is same on both sides in the denominator. The numerator is 5V times P and 5V times Pn. So Pn is going to be same as P. The new pressure is same as the old pressure which was there individually in each container, is going to be the new pressure Pn.